Welcome back. So we're at the very end of chapter 7 now, okay? 7-6b. So now we're going to work on solving exponential and logarithmic equations involving e and the natural log, okay? And again, awesome thing is our strategy is exactly the same as it has been. We just have to remember what those strategies are. So here, remember, to undo a logarithm, we need an exponent. So to take care of these logs, we're going to rewrite them in exponential form. Remembering as we go that ln is base e. So when we go to convert this to exponential form, e to the 2 equals x. Okay? Now you probably don't know what e squared is off the top of your head. So what I'd recommend is just type that into the calculator. Okay? Remember where e is right there? So e squared to 4 decimal places is going to be 7.3891. Okay? So same strategy. We're merely rewriting it in exponential form in order to solve this, remembering that all of these are base e. So e to the 3 equals 2x minus 1. So let's do some arranging here. So e cubed plus 1 equals 2x. So e cubed plus 1 over 2 equals x. So I'm just doing some linear transformation here. Add the 1 over, then divide by the 2. And now I'm going to want to type this into my calculator. Okay? And the way I recommend typing it in is to take care of the top. So e to the 3rd plus 1. Take care of the top, then divide it by 2. Okay? And that'll help you make sure that you're doing it right. Or make sure you put the top in parentheses if you want to do it in one big step. But here we get 10.5428. And that is going to be our answer. All right, so now for this one, I see subtraction. That is going to be the same as division. So this is going to be ln of 3 divided by x, giving me 2. But remember, this is base e. So when I go to rewrite this, e to the 2 equals 3 over x. So now I need the x. So I'm going to multiply the x over because I need it on top and divide by the e squared. Okay, so now that I have that, now I already have my answer. So let's type it in. 3 divided by e squared, 0.4060. All right, and this one, I see I have a power. So I'm going to want to bring that power out front. So 2 ln of x minus 3 equaling 4, because now I can simply divide by that power. Divide by 2 to give me 2. Now let's rearrange this. E to the 2 equals x minus 3. So if I want x, I'm going to have to add 3. And of course, I'm going to want to type that into my calculator. So e squared plus 3 gives me 10.3891. And that is going to be my answer. Okay, so exactly the same as what we've been doing. You just have to know how to manipulate and rearrange the logarithmic into exponential form. Now, what about exponential form? Well, remember, this is where we used logs to undo it. Now, remember though, e needs a base ln. So here, the cool thing is I can just natural log both sides when there's e involved. And the neat thing is ln and e perfectly cancel each other. So I get that. All right. Add the 2. And that types very nicely into my calculator. ln of 12 plus 2 gives me 4.4849. So these are nice because you don't even need the change of base formula. You literally just have to use ln. So that's super, super nice for us. Of course, if something else is going on, we have to be able to take care of that first. So I'm going to subtract off 5. And now I'm going to natural log both sides. By natural logging, the ln cancels the e, so I have 3x equals ln of 10. And so I just divide that 3 off. All right, so let's type that into the calculator. Natural log 10 divided by 3 gives me 0.7675. Right, or let's look at this one. I'm going to subtract the 2 first. Oops, I'm sorry. That should be 14. Subtract 2, divide by 4. So 14 divided by 4 is going to give me 3.5. Now I'm ready to natural log both sides, which of course the ln and the e undo each other, and divide by 2. So now I can go type into my calculator. I can type in ln of 3.5 divided by 2. That's going to give me 0.6264. So again, I really think that these are not that difficult. It's just remembering what that strategy is in order to solve them. All right, so let's look at a few word problems and then we will be done. So a spacecraft can attain a stable orbit 300 kilometers above Earth if it reaches a velocity of 7.7 kilometers per second. The formula for a rocket's maximum velocity, v in kilometers per second, is this. All right, so this is what we're going to be working with. The booster rocket fires for t seconds and the velocity of the exhaust is c kilometers per second. The ratio of mass the mass the rocket is filled with to its mass without fuel is r. So we have a lot of variables going on here. So suppose the rocket shown in the photo has a mass ratio of 25. All right, so mass ratio was r, so that 25 is going to go in where the r is. A firing time of 100 seconds. So firing time, that was T. So that goes in for my T. And an exhaust velocity as shown. So over here, this exhaust velocity of 2.5 kilometers per second, that goes in for C. They want to know, can the spacecraft reach a stable orbit? All right, so let's plug in, let's plug in each of those values. All right, so when I plug in each number to the place that I identify as it needs to go, now we can merely plug that into the calculator. Okay, so negative 0.0098 times 100 plus 2.8 ln 25. And it has a velocity of 8.03. And it says if it can reach 7.5 kilometers per second, it can reach a stable orbit. So this is over the 7.7. So yes, this will be able to achieve a stable orbit. And again, all you had to do in this instance was plug in the right values. Now, the time has finally come. So the next example we did back in the first half of chapter 7, but now we're going to learn how to do it without a table. We're going to learn how to do it using logs. So you invest $2,000 into a bank account that gives you a continuously compounding interest of 6.7%. How long will it take you to double your money? So to double my money means I'm going to be ending with 4,000. Remember, continuously compounding interest uses E. We need it as a decimal, and we're searching for the time. Okay, so writing it out like this, I can actually solve this now. Okay, we don't need a table. We can actually do the math to figure this out. Divide off the 2,000. Now I can natural log both sides. Well, the ln and the e cancel each other. So now just take ln 2 divided by 0.067, and that's going to give me the time. So let's go to the calculator. ln of 2 divided by 0.067 is going to take over 10 years. Okay, so about 10.3 years for you to double your money with continuously compounding interest. Okay? So I think it's really neat to see that now finally, on the completion of this chapter, we can finally more easily go back and do things that we did back in the first piece of it. Okay? So why don't you reflect on that? I think that'd be a cool thing to include in the summary. That relationship of what we did to how we can solve it now, or the relationship of even solving these natural equations compared to solving them we did back in 7.5. So just write out a summary and make sure you come back ready to do your practice work tomorrow.